Close your eyes and picture this. You're floating in the vast emptiness of space, when suddenly, a shimmering tunnel appears before you, a cosmic shortcut through the universe. You step inside, and in the blink of an eye, you emerge somewhere completely different. Not just another planet, but another galaxy, millions of light years away. No rockets, no decades of travel, just a single step through a mysterious gateway in spacetime. It sounds like something straight out of a sci-fi movie, but here's the wild part. Wormholes. These hypothetical bridges across the universe might not be pure fantasy. They could be real, and if they are, they'd change everything we know about space, time, and our place in the cosmos. The idea of wormholes comes from the same mind-bending physics that predicted black holes and the expansion of the universe. Einstein's theory of general relativity. Einstein showed that space and time aren't just a static stage where events happen, they're dynamic, bending and warping under the influence of matter and energy. Think of it like a trampoline with a bowling ball in the center. The heavier the object, the deeper the dent it makes. Now, imagine folding that trampoline so that two distant points touch. That's the basic idea behind a wormhole, a tunnel that connects to separate locations in spacetime, allowing for instant travel between them. But here's where things get tricky. The simplest kind of wormhole, known as an Einstein-Rosen bridge, was first theorized back in 1935. These wormholes would form as a link between two black holes, a kind of cosmic umbilical cord tying them together. Sounds cool, right? Well, there's a catch. These natural wormholes would be incredibly unstable. The moment anything tried to pass through, whether it's a spaceship or even a single particle of light, the tunnel would snap shut like a rubber band stretched too far. The gravitational forces inside would be so extreme that anything entering would be crushed or torn apart in an instant. Not exactly the smooth, Star Trek-style travel we might hope for. So, if wormholes are so unstable, how could they ever be useful? That's where exotic matter comes in, a hypothetical substance that defies the usual rules of physics. Normal matter, like the stuff that makes up planets and stars, has positive energy and creates gravity that pulls things together. But exotic matter would have negative energy, meaning it would repel gravity instead of attracting it. If we could somehow line the inside of a wormhole with this bizarre material, it might act like scaffolding, holding the tunnel open long enough for something or someone to pass through safely. There's just one problem. We've never found exotic matter. It might not even exist. The closest thing we've discovered is something called negative energy, which appears in tiny amounts in certain quantum experiments. But to keep a wormhole stable, we'd need enormous quantities of this stuff, far beyond anything we know how to produce. Some scientists think exotic matter could be hiding in the vacuum of space itself, woven into the fabric of reality at the smallest scales. Others believe it might be impossible to gather enough of it to make a traversable wormhole. Either way, until we find proof, this remains one of the biggest roadblocks to wormholes being more than just a cool idea. But let's say, just for a moment, that we could build or find a stable wormhole. Where would it take us? The possibilities are mind-blowing. A wormhole could connect to places in our own universe, letting us cross thousands of light years in a single step. It could even link different universes entirely, if the multiverse theory is correct. And then there's the craziest possibility of all, time travel. Because space and time are intertwined, a wormhole might not just bridge distances, it could bridge eras. One end could be here and now, while the other opens up in the distant past or future. Of course, that opens up a whole new set of problems. Time travel creates paradoxes. What if you went back in time and accidentally prevented your own birth? Would the universe just unravel? Some physicists think nature has built-in safeguards to prevent this, like the wormhole collapsing the moment anything tries to create a paradox. Others believe the laws of physics simply won't allow time-traveling wormholes to exist in the first place. So, if wormholes are so unstable, so hard to create, and possibly forbidden by the laws of time itself, why do scientists still talk about them? Because they push the boundaries of what we know. Every time we explore these wild ideas, we learn something new about the universe. Wormholes force us to ask deep questions. Is space truly as empty as it seems? Or is it filled with hidden structures we can't yet see? Are there shortcuts woven into the fabric of reality, waiting to be discovered? And here's the most exciting part. We are looking for them. Scientists study the cosmos for strange gravitational anomalies that might hint at wormholes. Some think tiny, Quantum-sized wormholes might flickering and out of existence at the smallest scales. Others speculate that if a wormhole passed between us and a distant star, it might bend light in a unique way that telescopes could detect. We might not have proof yet, but the search is on. Think about it, black holes were once just a strange quirk of math before we found them lurking in space. Gravitational waves seemed impossible until we detected them rippling across the cosmos. Who's to say wormholes won't be next? The universe has surprised us before, so could wormholes be real? The answer right now is maybe. They're allowed by the math, but nature might have other plans. Either way, the idea alone is thrilling. It reminds us that the universe is far stranger and more wonderful than we can imagine. And who knows, maybe one day, we'll find that first cosmic doorway and step through into the unknown. What do you think? Are wormholes out there, waiting to be discovered? Or are they destined to remain science fiction? Let me know in the comments, and don't forget to like and subscribe for more adventures into the mysteries of the universe. Thanks for watching, and I'll see you in the next video.
Hey there, if you're enjoying this video and appreciate the effort behind it, don't forget to like this video. It really helps the channel grow, and if you haven't already, hit that subscribe button and turn on the notifications so you never miss an update. Oh, and one more thing, share this video with your friends. Spread the love and support. Alright, now let's get back to the video. Let me know if you want any tweaks.